In cities around the world, many people are living and doing various activities such as commuting, shopping, and traveling. Urban transportation systems are supporting such activities and introduced to fit with the characteristics of each location. Hitachi aims to bring about greater convenience and comfort to people in cities. One of the ways to do this is our monorail system, which is currently changing the role of urban transportation in many parts of the world. In introducing a new urban transportation system, many factors must be carefully taken into account, such as transportation capacity, construction cost, and influence to the environment in terms of noise, sunlight obstruction, and so forth. Moreover, energy-saving greenhouse gas emissions also have to be considered these days. Hitachi's straddle-type monorail system overcomes all such issues and brings a more convenient and affluent society. Hitachi's straddle-type monorail system has already been introduced in Tokyo, Kitakyushu, Osaka, Tama, and Okinawa in Japan, as well as the Republic of China, Singapore, and the United Arab Emirates, and honorably received a high reputation. Hitachi's straddle-type monorail system features 3 S's: simplicity, suitability, and safety. Firstly, simplicity. Our monorail system has a very simple structure. Because of this feature, the monorail system blends in well with the surrounding environment. The entire system, including building and civil engineering processes, can be completed in a short period of time. As a result, it ensures excellent cost performance. Secondly, suitability. The monorail system is suitable for an urban transportation development project in any location. Hitachi monorail system easily adopts steep slopes and curves of small radiuses, allowing for a highly flexible line alignment planning. Its transportation capacity can be adjusted according to characteristics of each area that it serves. In addition, it features low noise levels and superb ride comfort, ideal for a new urban transportation system. Thirdly, safety. Hitachi's straddle-type monorail system has a non-accident operation record since 1964, attesting to its great safety and reliability. The system has safety-assured cars and a highly reliable control system. In addition to the 3 S's, simplicity, suitability, and safety, realized through Hitachi's original technology expertise, we provide full support in all phases of the transportation development project, from planning, design, construction, and manufacturing to operation and maintenance. Our aim is to make a full contribution to enhancing urban convenience and comfort. Urban transportation systems appear in various capacity, from large public systems to small private ones. It is essential that the selected capacity is the most suited for the site conditions, surrounding environment, and desired transportation capacity. Hitachi's straddle-type monorail system covers a range of transportation capacities equivalent to those of other urban transportation systems. With Hitachi monorail system, the number of cars per train can be flexibly changed, allowing for a wide range of transportation capacities and optimal model selection. This is why Hitachi Monorail system has been adopted as a means of transportation to serve recreational centers, access airports, and for complementing or linking existing transportation networks. In introducing an urban transportation system, it is necessary to verify the suitability of the system. Hitachi Monorail system has a bogie structure with rubber tires, which enables operation at a steep gradient of 6% and along small curves of a 40-meter radius. This allows for a highly flexible line alignment planning laid out in narrow areas, frequently inclined areas, or between high-rise buildings. Moreover, the monorail system can serve as an urban symbol that does not undermine the aesthetic beauty of the townscape. Let us now compare the construction of Hitachi monorail system with that of a general elevated structure transportation system. The general elevated structure construction begins with driving piles underground to lay the foundation. Columns are then erected and beams are installed using a crane. Slabs are installed on the beams to lay reinforced concrete tracks. As for the monorail system, foundation piles, required in a much smaller number because of the lighter upper structure, are driven underground. Columns are then erected and track beams are installed using a crane. This construction work can be carried out during the night without obstructing daytime road traffic and within a short period of time. In terms of construction costs, the monorail system can save costs by about 30% as compared to the general elevated structure. At the same time, the monorail can significantly shorten the construction period. An elevated transportation system in an urban area can give rise to environmental problems such as sunlight obstruction, as well as security problems such as illegal occupation of dead spaces. A general elevated structure tends to cast larger shadows because of its larger size. On the other hand, the monorail, with its simpler structure, allows more sunlight passage and is more effective in maintaining both scenery and security. Let us now compare how differently the general elevated structure and the monorail impact the surrounding environment in the following simulated images. Hitachi undertakes total planning for the project. This covers the entire range of monorail system development, including wayside equipment, vehicle, and the information system. Let us now take a look at each of these elements. Track track beams are manufactured in a dedicated factory so as to ensure high levels of accuracy and quality. Manufactured track beams can be easily and directly installed using a crane. In the Palm Jumeirah monorail project in the United Arab Emirates, a track beam manufacturing factory was constructed on the actual project site to realize steel framework assembly and concrete molding on the spot and complete this section of the project in a very short period of time. A track switch is assembled with several steel beams, each 5 to 6 meters long, that are shifted to switch train directions. There are several types of track switch. At Okinawa City Monorail's Shuri station, a 2-point track switch is installed. Osaka Monorail has a complex route structure on which smooth operation is ensured thanks to track switching. In Okinawa City Monorail's operation center, a 5-point track switch is introduced. Up to 5 directional changes are possible by monorail track switches, enabling the most efficient use of the limited space. Monorail car bodies are made of aluminium alloy to reduce weight. Non-flammable materials are used in the vehicle components and interior. Attention to detail ensures passenger convenience and comfort. For example, seats and windows can be arranged to optimize exterior scenery viewing. Passengers can walk smoothly through the sections connecting the cars. The air conditioning system ensures a comfortable ride. Dedicated spaces are provided for wheelchair users to enhance user accessibility. Emergency telephones are installed. Passenger information displays provide information on routes and schedules. The monorail has a double-axle bogie composed of rubber running tires and supporting tires. Each tire is backed up by an emergency wheel for use in the event of a puncture. The motor, brake, air spring, current collector, traction inverter, line breaker, filter reactor, auxiliary power supply, and battery are installed under the floor. The Operation Control Center can be flexibly designed, be it a large room equipped with several large display screens or a simple room staffed by a small number of operators. In either case, a computerized automatic train supervision system will ensure safe, accurate, and on-schedule train operation and operational efficiency. The monorail's signaling equipment is founded on technology that ensures the highest levels of reliability and safety. Real-time train control maintains a safe distance between 2 trains in operation and ensures safe and exact halts. Therefore, a large number of trains can be safely operated simultaneously, providing mass transportation when desired. high-voltage AC electricity supplied by a power company is received and converted into DC and supplied for train operation by the power reception and conversion equipment at the substation, which can be remote controlled just like the train operation control system. The station platforms are equipped with screen doors to ensure passenger safety. The doors open automatically once a train has arrived and stopped at the station. Sensors on the screen doors and train cars detect passenger movement and door functions. The doors close automatically once safety is confirmed. Half-height screen doors are also available to provide an unconfined atmosphere. Evacuation is possible in various modes if a train stops on the track due to a breakdown and in other emergencies. In the push-pull evacuation method, a disabled train is linked to a rescue train and moved. In the serial train-to-train evacuation method, the doors in the front car are opened to create an evacuation route through which passengers are led to a rescue train. In the parallel train-to-train evacuation method, passengers are evacuated through doors to a rescue train that is parked on the opposite track. If a rescue train cannot get near the disabled train, passengers can be evacuated using a spiral chute. Moreover, evacuation routes are provided between the tracks, and overhead rescue may be performed using a cherry picker. Hitachi straddle-type monorail system serves many people around the world. In Japan, it has become an important urban transportation means in 5 locations: Tokyo, Kita-Kyushu, Osaka, Tama, and Okinawa. Tokyo Monorail commenced its operation in 1964. It serves 11 stations over a total distance of 17.8 kilometers at a maximum operation speed of 80 kilometers per hour. Tokyo Monorail runs through an urban area on a route flexibly designed, a feature unique to the monorail, serving many passengers, including commuters and tourists heading for Haneda Airport. Trains depart every 3 minutes. The train leaves monorail Hamamatsucho station, runs through a built-up area with many tall buildings, and employs several slopes through the canal zone. In 2007, a side track was built at Showajima station in the middle of the route, enabling high-speed trains with limited stops, the first such service for the monorail. Passing Showajima station, the train arrives at Haneda Airport International Terminal Building Station, opened in 2010. Since the station is directly linked to the airport, passengers can quickly reach the check-in counter. After this station, the monorail runs underground and arrives at Haneda Airport Terminal 1 station and then Terminal 2 station, the terminus. Kita-Kyushu Monorail, inaugurated in 1985, runs 8.8 kilometers with 13 stations at a maximum operation speed of 65 kilometers per hour. Linking residential areas with Kokura in the city center, Kita-Kyushu Monorail serves as an important daily transportation means for local residents. Taking advantage of the monorail's structure, plants and flowers are arranged in the areas beneath the track near Kikugaoka station, enhancing the local environment. The section between Kitagata and Jono stations has a triple-decker structure, an ordinary road, the monorail track, and an express motorway. At Kokura Station, the monorail converges with JR Kyushu Station, providing smooth access to the general railway and Shinkansen bullet trains. Osaka Monorail commenced operation in 1990, serving 28 kilometers and 18 stations at a maximum operation speed of 75 kilometers per hour. This monorail is registered in the Guinness Book of Records for having the world's longest route. Osaka Monorail was constructed to alleviate traffic congestion in Osaka's central area by linking the monorail with other railway networks radiating out from the city center. The monorail route includes many hilly sections and curves as multi-level crossings and bridges were constructed over existing roads and railway tracks. Banpaku Kinen Koen Station provides a panoramic view of the Tower of the Sun, the symbol of Expo 70, held in 1970. In 2007, 2 new stations were opened on the Saito line, which provide access to Osaka's Life Science Center in the Saito district. The monorail route includes other landmarks loved by local people, such as a trussed arch bridge over an express motorway and 5 continuous Nielsen-Lose bridges over the Yodo River. Tokyo-Tama Intercity Monorail was inaugurated in 1998 and serves a route of 16 kilometers and 19 stations at a maximum operation speed of 65 kilometers per hour. The monorail runs north to south, connecting with JR East Japan's Tachikawa Station at Tachikawa Kita Station and Tachikawa Minami Station. Many students use the monorail on the southern side, where universities and other academic and cultural facilities are situated. It also includes a frequently inclined and curved section where it passes through the Tama Hills. The monorail mainly serves residential areas on the northern side and provides access to nature-rich districts on the southern side, including the Tama River and Tama Zoo. Okinawa City Monorail started operation in 2003, serving a route of 13.1 kilometers and 15 stations at a maximum operation speed of 65 kilometers per hour. An extension is scheduled for the future, with 4 more stations to be opened. Okinawa City Monorail was constructed to alleviate chronic traffic congestion. It links Naha Airport Station, often crowded with tourists arriving at this popular resort in Japan, with the central business district around Kencho Mae Station and Shuri Station in a hilly area. The monorail converges with a bus terminal near Asahibashi Station, forming a composite transportation network. Chongqing is China's 4th largest city under the central government's direct administration. Urban development is actively underway in this lively city. In 2005, Chongqing Monorail was inaugurated to alleviate serious traffic congestion and reduce air pollution. The monorail serves a route of 17.4 kilometers and 18 stations at a maximum operation speed of 75 kilometers per hour. The construction of a 3rd line of Chongqing Monorail is currently planned. It will run through the central area north to south and will be connected with the existing lines at New Jiaotou Station. Chongqing Monorail links the steep area near Jiadingjiang River with shopping and residential areas. In the section between Zhangjiayan and Dashigo stations, the monorail meanders along cliffs by the Jiadingjiang River and through pillars beneath ordinary roads. Between Xiejiawan and Yanjiaping stations, the monorail is linked with a shopping mall and a public square and runs through Julongda, becoming part of the park's symbol. The section between Dongyuan and Xinxiangcun stations is mostly residential, where the monorail serves as an essential transportation system for local people's commuting, shopping, and other daily activities. Singapore's Sentosa Island is an island-wide recreational centre complete with beaches and shopping facilities. Sentosa Monorail was opened in 2007 to provide better access to Sentosa from the southern edge of Singapore. It serves a route of 2.1 kilometers and 4 stations at a maximum operation speed of 65 kilometers per hour. Sentosa Monorail features colourfully painted trains in line with the island's atmosphere of leisure. Its narrow tracks help maintain unity with the surrounding scenery. Sentosa Station on the mainland side is situated within a shopping mall and is also linked with other shopping facilities and an underground network. Leaving Sentosa Station, the monorail heads for Sentosa Island across the ocean. Between Waterfront and Imbiah stations, the monorail passes the statue of Ma Lion, the symbol of Sentosa Island. And then climbs the steepest section of the route at a gradient of 6% towards Beach Station, the terminus. Serving the many tourists visiting Sentosa Island, the monorail has really become a symbol of the island. Dubai, the United Arab Emirates off the Persian Gulf on the Arabian Peninsula, is the largest cosmopolitan city in the Middle East. Many beaches and resort facilities are situated along the coastline, and several artificial islands are under construction. One such artificial island, and one of the world's largest areas of reclaimed land, is Palm Jumeirah. Palm Jumeirah Monorail links this island with the mainland. Its operation commenced in 2009 as part of the area's urban development. It serves a route of 5.4 kilometers and 4 stations at a maximum operation speed of 70 kilometers per hour. The 2 middle stations are scheduled for opening concurrently with the completion of several urban development projects in Dubai district. Leaving Gateway Station, the monorail crosses the ocean and runs through an area dotted with apartment buildings. After a long straight section, the monorail crosses the ocean again, passes Atlantis, the Palm Hotel, and arrives at Atlantis Aquaventure Station, the terminus. Since the Palm Jumeirah monorail is automatically operated without a human driver, the unoccupied train front offering a panoramic view is much appreciated by passengers. In dry, subtropical Dubai, the monorail serves international tourists visiting this resort as an essential means of transportation. Greater Daegu is in the southern part of the Republic of Korea. Daegu Monorail is currently under construction towards the scheduled opening in 2014. Daegu Monorail will serve a route of 23.8 kilometers and 30 stations at a maximum operation speed of 70 kilometers per hour. The monorail offers solutions to many problems: alleviation of traffic congestion, environmental preservation, low construction cost, short construction period, and energy conservation. As you have seen, Hitachi's straddle-type monorail system is in operation in many cities around the world, covering a total distance of more than 140 kilometers with over 580 cars. We at Hitachi look forward to offering our total support for your straddle-type monorail system development project with unrivaled technological expertise attested by our solid construction record.